Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new session in which we will understand the concept of properties, where we will deal with adjoint of A, adjoint of A, then we will deal with determinant and similar kind of things. So, from this part, you guys can expect one question, and if there is a chance that you may make mistake, it is the only part where you make mistake. Okay, so try to build better conceptual clarity about the concept. Okay, you have to memorize certain relationships and then you are good to go with the questions. So first, suppose that there is a matrix A. So we got our matrix. Now what we'll do, we will try to find out the cofactor of matrix A. This is your cofactor matrix. Now suppose that we are interested in finding the value of A times adjoint of A. First, try to understand what is adjoint of A. Adjoint of matrix A is transpose of cofactor matrix. So first you will find out the cofactor matrix and then you will take transpose. Transpose means converting rows into columns. So this is the thing. Okay. So we got our A times adjoint of A. Now try to understand what we will get in this part. You know that if we will multiply the elements of a matrix with its corresponding cofactor. So look at this. First we will multiply this thing with this thing, means A11 with C11 plus A12 with C12 plus A13 plus C1, A13 into C13. So if we will multiply the elements of a matrix with its corresponding cofactor, we will get determinant of a matrix. Correct? So here we will get determinant of A. Now, if we will multiply it with some other cofactor like this, we will get 0. If we will multiply this with this, we will get 0. Okay? Now we are done with the first. Now we will deal with this thing. So look at this idea. So if we will multiply this with this, we will get 0. Then we will multiply this with this, we will get determinant of matrix A. Then we will multiply this with this, it is not its cofactor, so it is 0. Now same game, we will multiply this with this, so we got 0. Then 0 and then determinant. Okay, and this is the matrix, means if we will multiply matrix with a matrix, we will get a matrix. Now you know that determinant is a number, and from matrix, if you wish to take anything common, you have to take something from every element. Correct now? So we will take determinant of A outside, and then we will be left with identity matrix. So we are left with IN. Correct? So can I say that A times adjoint of A or adjoint of A times A will be always determinant of A IN. This result is super important. From this result only we will be extracting all the different properties. Okay, so please digest this idea that A times adjoint of A or adjoint of A into A will be determinant of A IN. Comfortable? Now suppose that we have to take determinant on both sides. So I am taking determinant. Okay, be very careful. A times adjoint of A is equal to determinant of A I n. Now you know that this time it is not a matrix, it is a number, and means it is determinant. Correct now? So if you have to take something common in determinant, you know that from every row or every column you will take things outside. Correct? So this is a number and it is multiplied with all the elements. So from first row we will take determinant of A common, from second row we will take determinant of A common, third row determinant of A common, and we will keep on taking till n. So can I take determinant of A power n and then determinant of identity matrix, which will be 1. Now here also it is determinant of A times adjoint of A. You know that determinant is distributive when it is in product. So can I write determinant of A into determinant of adjoint of A, and we can eliminate one of them. So we will be left with what? Determinant of adjoint of A will be equal to determinant power n minus 1. So this is the second result that you have to digest. Okay, so till now we guys have studied A times adjoint of A is equal to determinant of A I n, and determinant of adjoint of A is equal to determinant of A power n minus 1. Correct? Suppose that you guys are comfortable till this part. Now we will try to level up this idea. Suppose that we we will play with this thing only all the time. Okay, suppose that we guys are replacing A with adjoint of A. Suppose, so how does this thing look like? So A will become adjoint of A dot adjoint A is equal to determinant of adjoint A, and in means I have replaced every A with adjoint of A. Correct? Now you guys are aware that A times adjoint of A or adjoint of A times A is determinant of A in. So what I wish to do, and you also know that while multiplying matrix, priority matters. AB is different from BA. So what I will do, I will pre-multiply with A. Pre-multiply with A. So it will look like what? A times adjoint A dot adjoint A is equal to, it's a number so doesn't affect, so it will become what? Adjoint of A and A times identity matrix will become A. Now you know that this entity will become determinant of A. Correct? So determinant of A adjoint A will look like, and you know that determinant of adjoint of A is determinant of A power n minus 1 times A. Now here is 1, over there it is 1, so we will divide both sides by determinant of A, so we will be left with adjoint A is equal to determinant of A power n minus 2 times A. So this is the second result that we have to digest. Okay, and also try to carry the pattern. So if it is a times, if it is adjoint of a times adjoint, yes, adjoint. Okay, now here also we will try to take determinant. I will connect all the dots, but for time being, suppose that we have to take determinant on both side. Okay, so it will look like what? Determinant of adjoint a is equal to determinant of a power n minus 2 a. You know that this is a number. Okay, so if you wish to, now this thing is what? A number is being multiplied with a matrix. So if a number is multiplied with a matrix, this means what? You have to multiply the number with every row. But what I'm trying to say, try to take things common. Okay, so from every row you have to take something common. Suppose that there are n rows. So can I say that determinant of n, it's a number? So number will be taken common from first row, second row, third row, fourth row, dot dot dot, nth row. So n times we have to multiply, and then determinant of a. So it will look like what? Base same, power add. So can I write determinant of a n square minus 2n plus 1, which look like determinant of a power n minus 1 whole square adjoint a determinant. And look at this, first time we have find out the adjoint once. Adjoint was written once, so it is a determinant of a power n minus 1, and here also determinant of a power n minus 1, but the power is 2. So if there are two things, power is 2. If there are one thing, the power is 1. So if there will be three things, so can I say that we will have adjoint adjoint adjoint. Now I'm using symmetricity, I will not take every list, every part, no? So can I write n minus 1 power 3, and things will keep on going. So suppose that this thing is keep on going, so it is adjoint adjoint adjoint, and then at the end also adjoint of a. Suppose it is k times. Why k time? I am not taking n because n is being already used. So adjoint is used k times. So can I write determinant of a power n minus 1 for sure, always, and then k. K decides the number of times you have used adjoint. Okay, so this is the idea. Now suppose that, look at this thing. Now you know that a times adjoint of a was determinant of a and then in, है ना? Now can I replace a with ab? Just think about it. We can do that. So this first a will look like what? ab times adjoint ab is equal to determinant ab in. Okay, you know that this ab, determinant ab, can be written as determinant a, determinant b, because determinant is distributive. Okay, now if you'll observe a is alone from this side, so can I pre-multiply with adjoint a? Okay, so I am pre-multiply with adjoint of a. So it will look like what? Adjoint of A times B times adjoint AB is equal to determinant A, determinant B. I have segregated determinant AB. Now adjoint of A. Okay, so this thing will become what? Adjoint of A times A becomes determinant of A I n. So can I eliminate this with this? Now who is this? This is B. So can I pre-multiply with B, adjoint B? Okay, so it will look like what? Adjoint B times B adjoint AB is equal to determinant of B. You have pre-multiplied adjoint B adjoint A. So you know that adjoint of B times B becomes determinant of BIN. So this thing on. So can I say that adjoint of AB is nothing but adjoint B adjoint A? So this is the next property that you have to digest. Okay, I hope till this part you guys are super comfortable. Okay, there is one more property. Please have patience. Now you know that A times adjoint of A is determinant of AIN. Now I want to replace A with K times A. Okay, for time being just go with the flow. Later I'll connect all the dots. Okay, now so this thing will become what? K times A. K is a number. Adjoint K times A. Determinant K times A I n. Now if you will observe this part, you know that K is a number. Number is multiplied with all the elements of matrix A. Now we have to take determinant of that matrix. So we will take K common from every row. So there are n rows. So can I write K power n determinant of A I n? Now you know that this K is a number. So this K and this thing will be eliminated, means we will divide both sides by K. So we will be left with K power n minus 1 determinant of A I n, and we will be left with A times adjoint of Ka. Okay, now what I will be doing, I will pre-multiply with adjoint of A because this A is alone. Okay, so pre-multiply with adjoint of A. So this thing will become what? Adjoint of A times adjoint of Ka. K is a number. So K power n minus 1 determinant of A, it's a number. So doesn't really matter. And then adjoint of A, and then In is okay. Now it will vanish. You know that adjoint of A times A becomes determinant of A. So can I write adjoint of Ka will be equal to K power n minus 1 adjoint of A. So this is your next property. I hope till this part you guys are okay. Now I will sum up everything all together. Please digest. So you know that the first thing that we have studied, A times adjoint A or adjoint A times A was determinant of A power in, sorry, times in. So this is the first property that you have to digest. Now, wait a moment. Now look at this. Now I will be dealing with adjoint, okay? So it is adjoint of A. So 2 times adjoint of A. Now come back again, backtrace. Dekho. So we have 2 times adjoint of A. So it is what? Determinant of A power n minus 2. Okay. So it is determinant of A power n minus 2. So there are 2 elements, that's why it is 2. And then we have A. Suppose that there are 3 things. So adjoint A. So there are 3 things. So determinant of A power n minus 3 A. Okay. Suppose there are 4 things. Adjoint adjoint A. So what you will be writing? Determinant of A power n minus 4 and then A again. Okay. So if there are 5 things, you know how to handle. So if it is, and also this is matrix, this is not determinant, that's why at the end you are getting matrix, because you are multiplying matrix number with a matrix, correct? So I hope this property is also clear. Now if they will give you 2026, 2027, 2028, then also you guys can handle. Now same thing we will handle by taking determinant. So determinant of adjoint of A. Now you know that once we have taken determinant of adjoint of A, it is determinant of A. This side it is determinant, so that side also determinant. Okay, means that side will have number. So determinant of A power n minus 1. Determinant of A power n minus 1. Now if there are 2 things, adjoint A. So what we will do? Determinant of A n minus 1 power 2. Suppose it is 3 things. Adjoint A. So what we will write? Determinant of A power n minus 1, then power 3, and so on. Is that okay? So this is you have to digest. If there are 4 adjoints, then you will be writing determinant of A power n minus 1 to the power 4. I hope this property is also clear. Then we have another property, adjoint of AB. You know that it changes its order, it reverses the order. So adjoint B times adjoint A. Okay, so if they will be writing A, B, C, adjoint of A, B, C, adjoint A, B, C, so you will be writing in reverse order. Adjoint C, adjoint B, adjoint A. I hope this also clear. Okay, then we have a number multiplied with it. Okay, so it was adjoint of K times A. So what you have to write? K to the power n minus 1 adjoint of A. I hope till this part you guys are okay. Till this thing you have to memorize. Okay, so A times adjoint of A is equal to adjoint of A times A is determinant of A in. Okay, Then without determinant, so adjoint A, and it is not determinant, it's a matrix, so at the end also we will get matrix. So determinant to the power n minus 2, because there are 2 adjoints. 3 adjoints, so n minus 3. 4 adjoints, so n minus 4 times A. Then we have determinant. So determinant means number at the end, number. So determinant will be determinant of A power n minus 1, and then we have to put power. If there is 1 adjoint, so power is 1. If 2 adjoint, power is 2. If 3 adjoint, power is 3. Then we have adjoint of AB. So it will change its order. Adjoint of B, adjoint of A. Then if you have a number multiplied with it and you want to take it outside, you have to write n minus 1, k to the power n minus 1. I hope the idea is clear, and this many properties you have to digest, and later we will apply these similar things into its appropriate questions, so we can develop better understanding about the concepts. And you can be sure that from this department only you will have one question. Okay, and if you want to extract the maximum marks, you should have a control over this part, because barely you guys will take 2 to 3 minutes to solve these kind of questions. I hope the idea is clear and you guys can handle similar situations. So see you guys in the next session of MathFlix.